So let's look at a few examples. Example 11. Find and classify all stationary points of this function, x cubed subtract 3x squared subtract 9x plus 5. Okay, so I want to go through this step by step with you so that you will be able to follow any of the questions that are being asked of you. Okay, find and classify all stationary points. So let's decompose what's being asked here. Stationary points refers to those three situations: local min, local max, or stationary inflection point. We want to find all those points, which means we need x and y coordinates for each of these points. And we need to classify them, which means we need to say which of those three situations we're looking at. So the first thing we want to do is find the derivative. The derivative function. Which is 3x squared subtract 6x subtract 9. Secondly, we want to draw a sign diagram of the derivative function. In order to do that, we need to be able to know what the critical values are. And remember, critical values on sign diagrams are asymptotes, and there are none in this function because there's no denominator. There's nowhere where this function is undefined. And zeros. So we know we're going to have zeros here. Let's find out where they are. So where does this function equal 0? Factor out a 3 and factor this thing. So x subtract 3 could be 0 using the null factor, or x plus 1 could be 0. So x is 3 or negative 1. Okay, we know though, so these are the critical values. This is where one of these three situations occurs. So we need the x and y coordinates of each. So determine xy coordinates of each point. So f of 3, we're looking at our original function. F of 3 is 22. Therefore, we have this point, 3, 22. And f of negative 1 is equal to 10. Therefore, we know we have this point, negative 1, 10. Okay, so we found the points. Now we need to classify them. Oh, we haven't drawn the sign diagram yet. Sorry, we need to finish that. So the sign diagram here, we have our critical values of negative 1 and 3. And if you're not sure again whether you should have plus or minus signs in each of these intervals, try some numbers in that interval into the function that you're making a sign diagram for. So in this case, you could choose a number less than negative 1, so negative 2, plug it into your function here. Choose a number in between -1 and 3, plug it into this function. Choose a number bigger than 3, plug it into this function. And are those answers positive or negative? That's where the signs come from. In this case, we've got a quadratic. This derivative function is a quadratic. We know that it opens up because there's a positive sign here. We don't see it, but there is one there. So this opens up, which means that we would need to be above the x-axis, below the x-axis, above the x-axis. Okay, but that negative sign should be up here for our sign diagram. Okay, so at this point, 322, if we take a localized look at that sign diagram just about the 3, we have negative over here and plus over here. What that means is that our function f of x is decreasing here until we get to 3 and then increasing. That means that this must be a local minimum. Again, if we take a look at our localized sign diagram just about the -1, it's a plus and then a minus, positive and then negative, which means that on f of x, the original function, we're increasing until -1 and then decreasing. So this must be a local maximum. Check to see if we've answered the question. Find and classify the stationary points. We found them, 322. We've classified it, local minimum. We found -1, 10, and we've classified it. It's a local maximum.